Welcome back, students, in a new video where we are going to discuss about the sign convention of a spherical mirror. Then we will understand the derivation of the mirror formula. We will go for the verification of the mirror formula with magnification, and at the end we will come across some simple numericals which you have to go for with the help of mirror formula. So let's start and understand about this. So sign convention, what is sign convention? When we understand or when we go for the sign convention, we have to see or we have to understand this sign convention makes us able to represent the quantities or various quantities related to the spherical mirror, such as the position of the object, position of the image, height of the object, height of the image, the focal length or the radius of the curvature of the spherical mirror which we are going to use, and more specifically their sign that which we are going to use, whether we are going to represent it with the positive sign or we are going to represent it with the negative sign, where we have to use that. So students, you have to be very mindful to understand the sign convention to solve the numericals in a correct way, because if you will not represent the quantities with a correct sign or with a correct symbol, then you will not be able to solve the questions in a good or correct way. So let's understand it in a very simple way. We will come across different new things which you haven't studied earlier. So this is a new concept which we are going to study, and we will carry on this thing under sign convention of the lenses when we will see for in class 10. So over here, when we are discussing about the sign convention, we will see for the spherical mirrors for concave and convex. So before I go for the concept of a sign convention over here, one simple thing which I want to recall for you all, which will help you to simplify, or it will help you to understand the concept of sign convention. Students, in maths, you all had come across the coordinate geometry. Over there, you all had drawn the graphs, and in the graph, you all know about the x-axis and y-axis. So over there, while you used to draw that graph with respect to the x-axis and y-axis, you know this thing that for the x-axis, when we go for the right side, it used to be in positive quantity, whereas when we go for x dash to the left side, then it shows the negative value. On the other hand, when we go for the y-axis at the upper part, we have it in the positive way, and when we go for the y-axis to the lower part, then we used to have the y dash that is in the negative way. So if you are familiar with this, or if you had understood this one, this mathematical concept, then it would be very easy for you to understand the sign convention, because when what we are going to discuss in the sign convention, that is only from this coordinate geometry. So all the values or the variables which we are going to use over here, it is respect to the x-axis and y-axis only. So all the things which we are going to use, that is going to represent its positive or negative value with respect to this x-axis and y-axis only. So the things which are going to lie on the x-axis to the right side over here, that would be in the positive value. The quantities which are going to be lie on the x dash to the left side over here, that would be in the negative value. Whereas those things which are going to lie at the with the parallel to the y-axis, that will be positive, whereas those quantities which will be parallel to the y dash axis, that will be negative. So these things we will understand one by one. So very first thing which you also which you know for that, that is a mirror. That is the spherical mirror. We are talking about a concave and a convex mirror. So you know for this thing that concave mirror and convex mirror both are the spherical mirrors which are the part of a sphere. When we cut a sphere and we coat its either the inner portion or the outer portion, then we can convert it into a mirror. So if we are coating it from the outside, then its inner portion is the reflecting surface which is acting as a mirror over here. So this is the mirror which I am talking about. So let's start with the concave mirror, then we will come across for the convex mirror. Some of the quantities would be the same and some other quantities will change over here. So say as for example, for making you understand, I'm drawing this y-axis and x-axis, which will help you to make the relation easy for you all. So over here, as just now I said this thing that for the x-axis, when you see for the right side, it would be the positive. On the y-x dash to the left side, it would be negative. And for the y at the top, it will be positive, and to the bottom side, it will be negative. So the distance of the object, the very first thing which we are going to see over here, that is the distance of the object. So say as for example, I'm naming this origin as O. So if you see through this figure, then the length OA, when you go for this length OA, that is representing the distance of the object, because here this AB is the object, and this is going to show the distance of the object. So distance of the object is represented with the letter U. We go for U, and as it is lying on X dash, so it will be in the negative way. So whenever the object has been placed in front of the concave mirror on the left side, we will use this U as negative. So again, I'm repeating this thing that you have to be very, very conscious about the sign, because if you are not using the sign correctly, you will not be able to solve the numericals properly. Okay. Now, the next thing we will go for the value for the distance of the image. So see over here, it is this value, that is OB dash. So over here in this particular figure, I'm using this OB dash. So in this one, you need to remember for this thing that we use it for V. So the letter V is represented for the distance of the image. Now, over here, you need to remember this thing that if the image is going to be real, if it is a real image, then the image is going to form to the same side of the object. Hence, it is going to form at the x dash axis only. Thus, it will be represented with the negative sign. But if it is a virtual image, then the image is going to form to the other side of the mirror or behind the mirror, which will lie on the x-axis. Hence, it will be in the positive sign. So you have to remember this thing very consciously, or very, very importantly, that for the real image, when we are talking about the real image, then it will be represented with the negative sign. And when it is when it is going for a virtual image, then it will be represented with the positive sign. According to the position, you can easily identify. You know for this thing that for the most of the condition in a concave mirror, we do obtain a real image only. There is only one situation where do we have a virtual image. So when we are having a virtual image, then it will be represented with the positive sign. So that these are the first two things which we have to remember. So first of all, we had one for the distance of the object, which is with U, and it will be always negative whenever it has been placed like this. And when we are talking about for the distance of the image, then it will be as for the real image. For the real image, it used to be negative, and for virtual image, it used to be as positive. So these were the two things. Now the next thing which you have to remember, that is the focus over here, the focal length. Students, these two things which we had discussed, that is the distance of the object and the distance of the image, it will be taken as the same for the convex mirror also. So as I was doing it for the concave mirror, so it is not like that for the convex it will be something else. So when we come for the convex mirror, then also the distance of the object will be taken as with U, and that would be negative because it is lying on the x dash axis. And when we come for the distance of the image, and as we know, for a convex mirror, the image used to be always virtual. Hence, the V would be there for the distance of the image, and that will be represented with the positive sign. Next thing, which as I said, that is the focal length. We are going to discuss over here the focal length. The distance of the focus from the pole is known to be as the focal length. And suppose, for example, we do have the focus over here on the pole. So for the concave mirror, when we are talking about the concave mirror, then our focal length will be always in negative. We will take it as negative. And with respect to this thing, when we come for the radius of the curvature, or when we say for the center the center of the curvature, that will be also negative. Okay, so why this is because we are taking the sphere as we know for this thing that spherical mirrors are the part of a sphere. So when we cut the sphere into two halves, such as like this, and if we put it's one of the end, one of the side, say as well on the outside, suppose when we are quoting it from outside, then its inner portion behaves like a mirror. So if we take our x-axis and y-axis on this pole with like this, then we do observe that the center of curvature, which is over here, and just a minute, I will change the color for this thing so that it will be highlighting this. So center of curvature, which is there, means the center of the sphere by which this mirror had taken out. The center is coming or it is lying on the x dash axis, so it will be taken as negative, and the focus is also going to lie over here only, so that would be also negative. So for the concave mirror, please remember for this thing that the focus as well as the radius of curvature, these both the components will be taken as negative. Whereas for the convex mirror, when we come for the convex mirror, and over there when we see, then we find that its center of curvature and its focus is lying to the other side, means it is going to lie on the x-axis only. Hence, we take its distance or its length as again f only we will represent, or r we will represent for the radius of the curvature, or you can go for the center of curvature only. That will be considered to be as a positive sign. Why it is been taken as positive sign? Because you can see over here that the focus and the center of curvature both are lying on the x-axis. So this is the reason why we are using it as positive. So these were the two things which you need to remember with respect to the positive and negative sign. Let's move to the next thing, and we see the height of the object and the height of the image which we have to use over here. So when we are talking about the height of the object, then always we used to keep, or mostly we keep the object upright or erect. So when we are doing so, then we are keeping the object parallel to the y-axis. And as we are keeping it parallel to the y-axis, we will see that which side it is going to lie, means from the origin, whether it is to the upper part or it is from to the bottom portion. So the height of the object when it is upright, then it is lying with the y-axis, hence it will be considered to be as a positive one, means the height of the object will be taken as positive. Whereas when we see for the height of the image which is going to form over there, that will be in two different conditions. That will be for the real. If I see for the real, then it will be negative, and for the virtual, if it is a virtual one, then it would be positive. So again, you have to remember for this thing. So as we had discussed earlier, that the distance of the image will be negative for the case of real, and positive for the case of virtual. In the same way, the height of the image will be also be taken as negative for the real image, and for the virtual image it will be positive, because you all had already understood this thing while we had discussed the image formation by the concave and convex mirror, that for the real image which were formed by a concave mirror, they used to be inverted, and when it is inverted, then it is parallel to the y dash axis, and because of this, that will be in the negative value. Whereas when the virtual images are forming, then we used to observe that it is parallel to the y axis, and that's why it will be taken as positive. So these were the things which we have to remember regarding the sign convention. So once again, this small recap: when we say for the distance of the object, that is used to be represented with letter u, and it will be always negative. When we go for the distance of the image, that will be represented with v, and for that real image, we do have it in negative. For virtual image, we do have it in positive. The height of the object is represented with the HOs, and it used to be positive. And for the height of the image is HI, that would be for real. For real, it will be negative, and for virtual, it will be positive. The focal length, when we are talking about the focal length, for the convex mirror, we will have it as positive, the focus as well as the radius of curvature, both the components would be in positive. But when we come for the concave mirror, then that will be negative. So you have to remember all these things, because with that only you will be able to solve the numericals. So I hope that you all had understood till here. Now let's discuss about the mirror formula. How we are going to do for this mirror formula, or what we have to understand in this one. So mirror formula is the formula which will help us to calculate different quantities regarding to the spherical mirrors. So when we come for the spherical mirror, the mirror formula states, so 1 by V plus 1 by U is equals to 1 by F. So over here, as we had already came to know about V, U, and F, we know all these things where we had studied just now that U represents the distance of the object, V represents the distance of the image, and F represents the focal length. So for a given spherical mirror, these are the components which we need to remember. Now, how could we derive this one? So here you can see there I had taken a concave mirror, and here I'm going to do a simple image formation. And with that image formation, we will establish the relation over here. So say as for example, this is the concave with the principal axis, and say this is the focus. This is the focus, and this is the center of curvature. Now, if I take any object which is placed beyond C, so if I'm keeping any object beyond C, then how the image is going to form. So as we had already understood the different rules for the image formation, so that we are going to use over here. So the first light ray I'm passing through the parallel to the principal axis, and as it passes through the principal axis, it will reflect back through the focus. Through the focus, we had studied about this thing. Now the next ray, I'm going to pass it through the optical center, or the center of curvature. So as I'm passing it from the center of curvature, you will observe that the light ray is going to return back or reflect back in the same path. So our image is going to form between C and F. So this is the condition which we are going to observe over here. So when we are putting the object beyond C, so just a minute, let me do this adjustment. Okay, so it's been done. So now, as I was saying, that when the object is placed beyond C, then we know this thing that the image used to form between C and F. So these are the things which we have to do for the ray diagram. Now, if I will place some names over here, then it will be easy for us to go for the proving. So say as this object is of AB, this image is of PQ, and over here, say as this point, we call it as O, that is the pole. Okay, and let's see, with this one we will do our derivation. So over here for the derivation, you have to use the rule of similarities. So in maths, you all had come across the similarity, or you will see the similarity in geometry, and as it is almost similar like the concurrency. So with that rule, or with that principle only, we will be able to establish the relation over here. So let's see. So first of all, I will take the by triangle PQC and triangle ABC. So I hope that you all can recognize the figure over here, PQC, this triangle, and the triangle ABC. So when we take these two triangles in this one, we can say like this thing that okay, so over here, this angle PQC is equals to angle ABC, because both will be 90 degrees. So both the angles are of 90 degree. And the second one, I can say for this thing that angle PCQ is equals to angle ACB. So both the angles are vertically opposite angles. So when these two angles are equal, so therefore by AA criteria, we can say this thing that triangle PQC is similar to triangle ABC. And when two triangles are similar, then their sides used to be in a proportion. So as they are similar in this form, so we can say like this thing, that PQ upon AB is equals to CQ upon BC. So I have to take just this much only. I will take till here. So make it as equation 1. Now we will move to the next equation or the next value. So again, I'm going to take for two different triangles. So triangle PQF. Now students, I'm going to draw one adjustment line. So what line I'm going to draw? So just see, as this is a curve, this side there is a curve, so we can't take a proper triangle. So I'm just drawing a line over here which will be almost equal or almost similar to that curve. So this is almost equal to these two curves. So over here, I will name, say as ABC is already there, I will name it a D. So this point is D. So DO or something like that. So I had taken almost, it is equal distance. So it is a small curve. So here I'm naming it as triangle DOF. Okay. Now, from these two triangles, if we go, then we can obtain again the similar kind of condition. We will take angle PQF is equals to angle DOF. So over here, both the angles are of 90 degree. The next one we can take angle PFQ is equals to angle DFO. So over here also vertically opposite angles. So when we do have again two angles are equal, so therefore we can say by AA criteria, we can say this thing that the triangle PQF is similar to triangle the triangle DOF. And when they are so, then again we can establish the relation of their sides in a proportion form. So we can say PQ upon DO is equals to QF upon FO. Now see student, here I'm going to change this DO. DO is going to be changed. So I'm going to change the equation and I will write it as PQ by, instead of DO, I'm going to write it as AB. Why? Because we know this thing that this AD line and this BO line, both are parallel to each other. So when they are parallel to each other, then their distances will be equal. So when their distances are equal, so we can consider that they are equal only. So DO and AB is equal. So it is equals to QF upon FO. So this is equation 2. So when we come across these two equations, then we see that both the equation contains this QF by AB. So we can say like this thing that by equation 1 and 2, we can say that CQ upon BC is equals to QF upon FO. So this is the main component which we had obtained by taking these two triangles similar, these two sets of triangle similar. Now let's move to the second part of the derivation. So for that one, let me just clear this portion out so that I can use the other components. Now, when we had got for this value, we will use the sign convention, and with the help of the sign convention, we will be able to establish the relation over here. So as you all can see, for by equation 1 and 2, we got for this particular quantity. Now we are going to use the sign convention. So for CQ, we don't have any proper sign convention for CQ. So what we will do over there, so with the figure only, you all can see that for CQ, I can write OC minus OQ, as I don't have any particular sign convention for CQ. Now BC, again BC also I don't have any particular sign convention for that one. So again, through the figure only you can see OB minus OC can be written over there. it is equals to QF. So again, QF, I can't go for any sign convention for that one. So I will say that it is OQ minus OF, and then OF or FO, that I do have a sign convention, because that we had understood it's the focal length, which we had taken earlier. So it is represented with the small letter f, and as it is a concave mirror, I'm going to take it as minus f. So I will put it as minus f over here, and that was from the sign convention. Now let's move to other things. So OC, I do have OC over here. So if you all see, then OC is the radius of the curvature. OC is the radius of the curvature, and there is another rule when we go for the radius of the curvature, that is equals to 2f, the two focal length. This we had already discussed while we were discussing about the different components related to a spherical mirror, such as the principal axis, focus, center of curvature, pole, all those points. So over here, instead of writing for r, or the radius of curvature, for OC, in place of OC, I can write it as 2f. Now, as it is for the concave mirror, I'm taking over here, so it will be taken as negative. So minus 2f, then again minus OQ. Now, what would be the OQ will be representing over here? So if you see this OQ, then the OQ is actually the distance of the image over here. It is the distance of the image. So I can write it as over here. We know for this thing that it is a real image. So for this one, we can mention it as minus V. Next upon. So the next component is OB. So over here, OB. So what OB is going to represent? So OB is the distance of the object, and we know for this is minus U. Then minus OC. So what is OC? Again, we know for that one, that is minus 2F. It is equals to OQ. What does this OQ is representing? So it is the distance of the image. So that is minus V. Then minus OF, what that is representing is representing the focal length. So it is minus F upon minus F. So now let's just go for the simple algebraical expression and simple algebraical simplification. So minus 2F plus V upon minus U plus 2F equals to minus V plus F minus F. Now, if we go for the cross multiply for this thing, then I will get it as minus F will be multiplied with minus 2F plus V equals to minus V plus F with minus U plus 2F. And students, just follow the algebraical rule. Just follow the algebraical rule over here. So when you are going to simplify here, it is going to be as positive 2F squared minus FV equals to, over here, when you are going to simplify for this one, you are going to get UV, then you will get as minus 2FV. Then when you are going to multiply for this one, it is going to be as minus FU, and over here when you are going to multiply, that is going to be as plus 2F square. So easily you can cancel this 2F square and this 2F square. Then in the next step, you have to just take the like components. So as here you have minus FV. If I will bring this this FV from that side, it will be as plus 2FV, that is equals to UV minus FU. Okay, simply we are just doing the algebraical expressions and the algebraical calculations. So over here, when you are going to solve this one, it is going to be FV equals to UV minus FU. Okay, so I will just clean out this upper column so that I will get some space to go for the further calculation. Okay, just a minute. Okay, so now I will take this column up over here. Okay, just over here. Sorry. Now let's continue for this one. So in this one, further when I will go for the simplification, I will just alter the position. So that is FV plus FU equals to UV. Now this is the equation, and we will divide both the side by UVF. Okay, so dividing both side by UVF. So when you are going to divide it, so it is FV upon UVF plus FU upon UVF equals to UV upon UVF. Then what are the components you can cancel? So F and V can be cancelled. So over here you can cancel this one with F and V. Here also F and U can be cancelled. So U and F will be cancelled. So U and UV and U and V can be cancelled. So ultimately you are getting at the end over here 1 by U plus 1 by V is equals to 1 by F. So this is the mirror formula which we used to get, or you can write it as 1 by V plus 1 by U is equals to 1 by F. Both are the same things. So there is no any problem regarding to that. So this was the mirror formula, or this is the thing which we have to derive throughout this whole figure. So all those components which we come across with that one, we know for this that mirror formula stands for 1 by V plus 1 by U is equals to 1 by F, or we can say 1 by U plus 1 by V is equals to 1 by F. So this was the mirror formula which we have to understand. So I hope that you all will practice this one, because this is an important component which we need to study. Now, let's discuss about the verification of the mirror formula, that how we can verify this mirror formula, whether this mirror formula is correct or not. So to do the correction or to the identification of this mirror formula, we just need to go for a simple logic, and with that one we can establish this mirror formula is very much correct. Students, we had already studied about this thing, that when the object is placed in front of a concave or a convex mirror, when the object when that object is at infinity specifically, then we know for this thing that the image used to form at F. That is the very basic concept which we had understood. So suppose, for example, if I draw the ray diagram for both the condition, for the concave and convex mirror, when the light rays are coming parallel to the principal axis for the object which has been placed at infinity, then the light rays are going to intersect at the point focus. And when they are going to intersect, then we will observe that the image is going to form at focus only. So over here, like this. For the convex, it will be like this. It will be like this. And when we will produce it, when we are going to produce this light ray, then it is going to intersect at focus. Over here, it is going to intersect at focus, and here it is actually intersecting at focus. So for this condition only, we will use the mirror formula to establish that whether this rule is correct, or the things which we had drawn or done over there, that is correct over there. So we know this thing, that 1 by V plus 1 by U is equals to 1 by F. See, for this situation, for both the condition, U is at infinity. We don't know its exact position. So when we come across for this formula, then 1 by V plus 1 by infinity is equals to 1 by F. For this particular equation, this has no value. So it will be 1 by V is equals to 1 by F. And with respect to that one, we can say this thing that V is equals to F, means the image which is going to form, means the position of the image. V is representation of the distance of the image from the mirror, and that shows the F. It means that the image is going to form at focus. So hence we can establish the relation that yes, the mirror formula which we had derived right now, it is completely correct. So that was the verification of the mirror formula. Now let's discuss about the magnification. So what does this magnification means? When we come across the different image formation by a spherical mirror, whether it is a concave or a convex mirror, then we know this thing that the height of the image used to change with respect to the height of the object. So magnification is actually a justification, or it gives us the understanding that what would be the size of the image with respect to the size of the object when it has been placed at a certain distance from the spherical mirror. So that can be understood. So when we go for the calculation of magnification, then it is, as I said, that it is the ratio of the height of the image with respect to the height of the object. Hence, it is equals to hi upon ho. And this can be equals to minus v by u also, because when we establish the relation with respect to the sign convention, then we observe this thing that that magnification can be also be established with minus v by u, because as we had just now understood that for a concave mirror, when we had drawn the different components such as the position of the object, position of the image, and with respect to the position, the height of the object, all those things when we had come across, then we had understood the different concepts. So when you come across for those things, you will observe that the height of the image and height of the object with respect to the sign convention will come under minus v by u. So hence, when you go for the calculation of magnification, you just use the simple formula hi upon ho, which will be also equals to minus v by u. In the case of the spherical mirror, when we will come across lenses, when we will see for the lenses over there, the component will have a little bit of changes. So these are the things which you need to remember for your calculation. So with this, you can do your calculations in a correct way. Now, as I said that we will discuss about some of the simple numericals. So let's see and do over here that how we can understand to calculate the different components. So here is the first question. Let's discuss about this first question. So here the question says that an object of 4 centimeter in size is placed at a distance of 25 centimeter from a concave mirror of focal length 15 centimeter. Then find the position, nature, height of the image. See students, I used to recommend my students always this thing that whenever you go for the numericals, first of all, you write the components what is given in the question. So whatever the components are present, you just use those components, and with that components, you will be able to do the calculations in a correct way. So very first thing which we can come across with this one, that is the height of the object. So we can write height of the object is equals to 4 centimeter. Next thing, it is given that it is placed at a distance of 25 centimeter from a concave mirror. So when it is a concave mirror and it has been used, so it is as minus 25 centimeter. Then of focal length 15 centimeters. So you go for the focus, that is going to be as concave mirror, it is minus 15 centimeter. Next, you need to find the position of the image, then the nature and the height of the image also. So how you are going to do the calculation over here? Very simple thing you can use, and with that one you can do all those things. So just a minute, let's see over here. So just now we had come across the formula, and it says that 1 by v plus 1 by u is equals to 1 by f. So if I will see for this, then I can say 1 by V is equals to 1 by F minus 1 by U. So 1 by F is minus 15 and minus 1 by U is minus 25. So it is minus 1 by 15 plus 1 by 25. So when you are going for the calculation of the LCM for 15 and 25, so what that would be? So I think 125 or 120. So this C for this one, or 75. Yes, 75 would be the LCM. Okay, so let's take, so 75. So 75 is the LCM. So over here it's minus 5. And over here you are going to get it as plus 3. So when you are going to solve for this one, it is going to be minus 2 by 75. So therefore, when you go for the position that is V is going to be as minus 75 by 2. So when you are going to divide for this, one, then it is going to be minus 37.5 centimeter. So this is the position of V. This is the position of V, means the distance of the image from the mirror. Students, a small trick I will share with you all. When you have the position of U and F, with respect to that, when you come for the V, then you can easily relate them to identify the position of the image, to justify the properties of the image. So over here, when you see this U is 25 centimeter and the focus is 15 centimeter. So when focus is 15 centimeter, then obviously the radius of curvature would be 30 centimeter, and the U is 25 centimeter. It means that the object has been placed somewhere between F and C. So when the object been placed somewhere between F and C, then its image used to form beyond C, as we know for the characters. Thus, you can see that it is beyond C over here, and it will be real, inverted, and large in size. So large in size. So like this, you can be able to calculate, as well as you can be able to relate it with the character of the image formation, and with that one you will be able to solve the question also. So this is the thing which you have to do in this particular question. Let's see some more questions. So I don't have a lot of questions, but just only 2 or 3 questions we will discuss, and then I will end up the class. So over here in this particular question, you can see that I had used these things. So just a minute, I will use the marker. Okay, so a 4.5 centimeter needle is placed 12 centimeter away from a convex mirror. Okay, over here we are having the convex mirror of focal length 15 centimeter. Give the location of the image and the magnification. Okay, and how we can calculate it for that one. So over here, okay, in the previous question also, height of the image had been asked, but I forgot to calculate for that one. But I hope that you all can do it by your own, because you know for the calculation that it needs hi upon ho equals to minus v by u, and with that one you can simplify. In this question, I will go for that one. So over here, when we see for this thing, again, do the same thing as I had asked earlier. Whatever the questions been providing, you write those quantities. So first of all, here we need to write these things. So that is height of the object, that is given 4.5 centimeter. Then it has been placed at a distance of 12 centimeter from the convex mirror. So we will go for the U, that would be equals to minus 12 centimeter. Then we have the focal length, as it is a convex mirror. Please remember, for the sign convention, it would be plus 15 centimeter. And now we have to calculate the V. We have to go for the calculation of V over here, and then we have to go for the condition, as well as we have to mention this statement. So I will come to this last statement later on, but first go for the calculation. So over here we will use the same formula: 1 by v plus 1 by u is equals to 1 by f. 1 by v equals to 1 by f minus 1 by u. Just put the values. That is 1 by 15 minus 1 by minus 12. So it is 1 by 15 plus 1 by 12. So the LCM will be 60. So 4 plus 5, that is 9 by 60. So therefore, V is equals to 60 upon 9. Now you can cancel this one, and with that one you will get it, get some value in decimal. So with 3 you can cancel 3 times and then 20 times. So it is 20 upon 3. So it is going to be as 6.66. You can take it as a round up value of 6.7 centimeter. Now, the second part, you have to go for the magnification. You have to go for the calculation of magnification. So M is equals to, so that is HI upon HO. But I don't have the height of the image, but I do have minus V by U. See, here I don't need to calculate the height of the image. Hence, I will not use this particular quantity. I will just only go with this quantity because the question is asking only for the magnification. So over here minus. So minus is the common, that's the formula value. And over here I'm using this 20 upon 3, and U as we have minus 12. So this is going to cancel. So it is 20 by 3. Okay, so it is by into 12. So here, if I'm going to simplify for this one, it is going to be 20 by 24. So if you will cancel with 4, it is going to be 5 upon 6. So when you are going to divide it, so you will get 0. What I say, 0.8, something 0.8, you are going to get it over there. So this would be the height of the image which is going to form. And with this one you can see that sorry, not height of the image, this is the just this is only the magnification. Height of the image would be something else. This is only the magnification. Okay, let's see the calculation of height of the image also, because in the previous question I haven't solved for the height of the image. So if I have to go for the calculation of the height of the image, what it would be? So height of the image upon height of the object is given 4.5, it is equals to minus V. So minus that is 20 upon 3 by minus 12. So this minus and this minus will be cancelled. So height of the image is equals to 20 upon 3 into 12 into 4.5. So if I will remove this decimal, I will get it 10. So this 0 will be cancelled. So if I will go for the cancellation, this one and this one will cancel for 15 times. So with 3 I can cancel for 5 times, and this one we will go for 4 times. With this one and this one I will cancel it. So it will be 5 by 2. It is going to be 2.5 centimeter. So it is going to be 2 centimeter less than to the height of the object which is there. And this is the magnification. Please remember, students, that this is the magnification. It will not be written with any unit. Magnification doesn't comes with any unit, but height of the image do come with a unit. So over here we have to remember this thing. So this was the calculation which you have to do for this one. Okay, now as I said that I will come to this the second part. The second part is also very important for us to understand. So describe what happens as the needle is moved farther from the mirror. See, student, this is a convex mirror, and while we were discussing about the image formation by a convex mirror, I had said this thing that when the object is placed in front of a convex mirror anywhere, then its image used to form to the other side of the mirror, and it used to be forming between the focus and pole, and it is virtual, erect, and smaller in size. But if we change the position, means if we are just moving a little bit closer or a little bit far away, we will observe that even we are doing so, the position of the image remains constant between the pole and the focus, and the size remains small. Only a little bit would be changed. But if the object had been moved very much far away from the mirror, in front of a convex for the case of convex mirror, then we will observe over there that the image is going to form at focus, where it is going to be formed very small in size. Even though the nature of virtual will be maintained over there, the nature of erect will be maintained over there, but the size of the image will get smaller, and it will form at the point F. Instead of forming between the pole and F, it is going to form, or it will form at F. So that was the thing which you need to remember over here. So this was another calculation which we had to do for understanding the concept of the mirror formula. Now let's move to the another question. So this is the last question. This is the last question which we are going to discuss, and then I will end up this lecture over here. So let's see in this question, what does this question shows? So an arrow of 2.5 centimeter is placed at a distance of 25 centimeter from a diverging mirror. Okay. We had already discussed about what are diverging mirrors and converging mirrors. We know for this thing that concave mirrors are converging mirrors and convex mirrors are diverging mirrors. So sometimes questions can be with that name. So diverging mirror of focal length of 20 centimeter, find the nature, position and size of the image. I hope you all can do this thing. I will just give you a simple guide for that, and later on you all do, and I think that you will get a correct answer for this one. So height of the object is 2.5 centimeter. Then you have the distance of the object as that is u, that is minus 25 centimeter. Always u used to be the negative one, and then v I don't have over here, but the focal length, that is the diverging mirror, so it is a convex mirror, so it will be taken as positive, so that is positive 20 centimeter. And now you have to find for the v the nature of the image formed as well as the size of the image which is going to form. So these are the things which you need to go for the calculation. So I had already explained that how you can use the formula, and with that formula how you have to solve it. So you just go for that equation, and with that one you will be able to do the calculation. And I hope that you all had understood this thing. And please practice all the things whatever we had come across. You please practice, and wherever you do have any problem, we will discuss it in our online classes. Okay. So then I'm ending up our class over here for today, and again we will meet again in a new live discussion, and over there we will discuss some more things. So thank you everyone, and please practice. Bye.